Hello everyone, welcome to another episode of our Farming RPG tutorial series. So here's a little recap on how our farming system works. So the player is able to till the land and make changes to the state of the land as he wishes. He's able to plant seeds, cultivate them by watering it. And for every second that the land prefab remains watered, the plant will grow. Now, when I leave this scene, the information of all the crops and all the land plots are saved and recorded so that when I return back, they'll be loaded into the scene and all the changes that I make to my farm is retained. But as long as I am outside of the farm, time basically stops. Because our farming system is dependent on Time Manager's tick function. So on every tick, Time Manager informs land of the change in timing, and then the land class will do the necessary changes. Problem is, the moment the player leaves the scene, the land class is destroyed. So when time advances, we get an error. This is because we forgot to unsubscribe from the Time Manager tracker list. So what we can do in our land class, an onDestroy method, there. So now we shouldn't be getting the error anymore, but it doesn't change the fact that time basically stops for the crops because the land class is destroyed. Now what we did for the saving system is that we convert all the data into the land save state and a crop save state, and then it just sits there until we come back to the farm scene. So what we can do for time to continue affecting these crops is to also play with the numbers here as if the player was still in the scene. So under land save state, let's do a clock update function. Simulate what it would do if it was a land class. Let's just take the whole function here, paste it here, and just remove the things that we don't need. Then we check the hours that passed. Instead of time water, it's last water. Now, since this is the safe state of the land, we don't need to deal with any of the crops. We just need to focus on the land being a piece of land. We don't need this. We don't need this. What we really need is to dry up. Dry up is to switch back to farmland. There's no switch land status function because we're just working with the safe state here. Likewise, we need to simulate the growing and withering of the crops over in crop save state. So let's create a function for these. Let's copy it from crop behavior. We have a problem here because seed to grow is a string. So we need to convert it back into seed data first for any of this to work. We can use inventory manager's item index that we made in the previous part. But this returns an item data. We want the seed data, so we just cast it like this. Our next problem is these variables like max health, max growth, because these variables are dependent on the seed data. So we just have to extract it. Now, how do we get the max health? It's by hours to minutes. Okay, and then how do we get the max growth? Hours to grow. Right. So max growth, first have to take the days to grow. First the seed info stores it in days. Then we have to, after days to hours, we have to convert it into to minutes. Okay, now that we have gotten this, keep the statement, crop behavior. We don't have a switch state function, it's just to do the data changes ourselves, like that. There is no LAN manager to inform, so we can just get rid of this. With that, we're done with our grow function. Now to do the wither. Withering seems a lot easier. And that's it. We're done with the functions here. So now what we want to do is basically, you see, our LAN manager stores these safe states with a static variable, the LAN data and the crop data. So what we want to do is somehow get these to subscribe to Time Manager, and every time Time Manager updates, it will update the data over here as well. To do this, we should create a new class. Let's call this game state. Actually, let's create it outside of here. It's not directly in our safe system because we want it to mostly just manage the game state. And we want this to be a singleton. So let's get it from like a singleton class. And this will be the class that will be updating our static variables according to the time notifications. So let's make it an iTime tracker. Recommend the clock update interface. To update it, we first need to register the tracker with Time Manager. So in the start function, okay, now that it's subscribed, we first need to check what scene we're in, because we only need this to work when the player is outside of the farm scene. As long as the player is in the farm scene, then Time Manager can just inform the LAN of the state changes and then everything is good. But only when LAN is unable to do its time things, then Game State Manager will take action. So let's create an if statement, current location, because that's how we know the current location. The location is anywhere that is not farm, so it's not equal. And then first we need to retrieve the static variables from LAN manager. So right now the farm data is in a tuple. LAN first, LAN is the first item, and then prop is the second item. Now, to make things as optimal as possible, we only want to do the updating of land plots that already have something planted, so that we don't iterate through all plots of land, because there's like over 400 of these. So to be more efficient, we're just only going to update every piece of land that has a crop planted on it. So if that's the case, if there are no crops planted, just going to return if it cannot find any crops planted. That way it's going to save a lot of processing data. Now, usually in our farm, the land affects the crop. Like the land has the clock update, and then from the clock update, it updates the crop that is planted on it. In the game state, since we're focusing on crops, it's going to be the other way around. So we'll be iterating through each crop data instead. So let's create a for loop. Get the safe state that is positioned in the array. Now, how do we get the land safe state from the crop? Using land ID. Yep, I forgot about this. So each crop save state records the land ID. So we get the land save state. And this land ID corresponds to its array index. Okay. The reason why we want to update the clock is to continue to grow the crop as long as there's water on the land, or if there's no water on the land, we want the crop to start its wilting process until it's wilted. So we just have to check the crop state, see if it's already wilted. Because once it's wilted, we don't need to care about the crop anymore. Its other stages, seed, seedling, and in its other stages, time still affects it. So wilted is the only state. Okay, what it's going to do first is update the land, right? Because every 24 hours, it's going to switch back to farmland. Land. First, we're going to update the land state, and then after we update the land state, update the crop state on the land. So to update the land state, it's land clock update. Just define it. Oh, and then the timestamp would be our current timestamp. Now that we have it, the crop will either grow or wither depending on the land state. So the land status is watered, crop will grow. If not, it will wilt. But withering needs two conditions. The land status is not watered, and when the crop is not a seed, it has to germinate before the wilting process is able to start. So we'll make this a condition. Then wither. Now this alone will not update the static variable. So after we're basically done with the loop, wait, we first have to update the array element first. Because this is a struct, it's not a reference, so all the changes that we make here have to be put back into the array, else it will not save. Likewise for our list. Let's see if this works. Let's do a little bit of debugging. See if the variable updates. Need to add a game state manager over here. I'm planting 2 cabbage seeds. And we see its health advancing as time goes by. So we know that it's working. It's reached its max health. And its growth is stuck there because we have not watered it. So let's go back, water it, and it continues growing. Oh, its health is decreasing because it has grown into a seedling and it's not watered anymore. Yep, so from this we know that our system is working basically as time advances. So let's get on to sleeping. So let's go on to play a home scene. And there's a bed here that we want the player to interact with. Instead of mesh colliders, to make things easier, let's have a box and should be shorter than the player. What we want to happen is basically when our player goes home, goes on his bed, and he interacts with it, there'll be a prompt asking him, would you like to sleep? And then from there, if you click yes, the player sleeps. Click no, then the player doesn't sleep. So to do that, let's make a prompt for it in the UI. We don't want it to only be for sleeping though, because in future there'll be other yes no prompts as well. Like if the player talks to people and stuff like that. So we want to make it a bit more generic. To do that, create a on the canvas, create a new image. Should be behind the inventory panel. So this yes no prompt. Okay. So when the player interacts with the bed, this will come out, but the text here will change. And when the player clicks yes, an action will be done, right? It's not always going to be sleep, right? There are different contexts for this. So we're going to make this more generic. So let's create a class to handle this. Create a new script under the UI folder. Call this yes no prompt. And then we'll place it here. We need the UI to access the prompt text. Okay, now in this prompt, you just have to assign the text to the prompt text. Now we just need to handle the code that deals with the action. So we'll be needing action on yes, I call it on like this selected. So this is the using system. Right, so it's basically a delegate that will trigger when the player selects yes. Now we just need a function, create prompt, to take in the message and the action. And we're going to display the prompt. And yeah, that's about it for displaying the prompt. Now we have two buttons, yes and no. And on click, when they're going to click, they need to call a function here. So if the player clicks yes, it'll call this action. If the player clicks no, it should just close the prompt and nothing happens. Do this, since this will handle yes and no, we'll put in one more parameter. Yes. Oh, we have to make sure there's nothing here by default. So if yes, action is not null. And then we reset the action to just to prepare it for any future time this is activated. And then we just have to set active to the false. So if it's no, only this part gets executed. If yes, the whole thing gets executed. Now so when the player clicks yes on click, it calls the answer function with a boolean of true. In no, if no is selected, it calls the answer function with a boolean set to false. Now we just have to uncheck this because it's not supposed to be active by default. So how do we get this to be active? The trigger will be in UI Manager. Let's open UI Manager. Let's add over here. Set it to this. And then we'll add a function. For that, let's organize this a little bit. And we'll do this through a function. This will take in the action. Okay, now that we have the yes no prompt done, we can work on the bed. Now we want the player to interact with the bed. So on the bed, let's create a new script for this bed. Since we already have the groundwork to interact with objects under interactable objects, we'll make bed inherit from object. And we're going to override pickup function. Going to do its base, but trigger the yes no prompt message. We wanted to ask, do you want to sleep? And then we need a sleep function. Sleep can be handled through the game state manager. Let's create a new function. Now, how do we want to sleep? Wait, first we put in the bed and it's item. Remember to set this to item. Oh, save this. Just make this a prefab. For now, let's debug.log sleep. See if it works. So right click, the prompt comes up. If you click no, nothing happens. Click yes, I get this sleep. So it works. So now let's handle the advancing of time in sleeping. Because we have a time system that just handles every time-based object in one place, so all we have to do is just keep calling the tick function until it's 6 a.m. the next day. So to do that, we need to calculate how many ticks it would take for the time to reach 6 a.m. And then we just have to loop it that number of times, basically. So basically need to... Right, so to calculate, first we need a timestamp of 6 a.m. the next day. So to get the timestamp, it's basically our time. We get the game timestamp first, then with the timestamp, we modify the values of the day. There's an addition of 1, and then we just set the hour to 6, because it's 6 a.m. And then the minutes should be 0, because 0600. Let's check if this is correct first. Yep, it's correct. So now we need to basically convert this into minutes and then convert our current time in minutes, and then we minus them off, and then the result is basically the number of ticks that we need. So to do that, let's go to game timestamp. We've never made a conversion function for that. And it's basically hours to minutes, this whole stretch. That's the minute. Yep. And now with that, in Time Manager, let's create a function to skip time. And let's convert it to minutes. Just call this in minutes, so it's confusing. In minutes. Let's debug this. That will be our timestamp. And on sleep function, let's call Time Manager, do a sanity check. Let's adjust the collider over in the house a bit. Just lower it, just so the player is able to interact with it. Okay, so we see that it's able to convert the time to skip to time now. Right. Yep, the math is about right. So that's how we know it's correct. So the difference, so we calculate the difference. Right. Then we start the loop. But first we need to check if, because there's a possibility that player might give a time that has already passed. Because it cannot be a negative value. Now for the for loop. We call the tick. When the player sleeps. Bam. Next day. Bam. 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 So it works. Player is able to sleep. Now we want a nice transition. We don't want to just call the skip time function directly. We want, when a transition, the scene fades to black and then bam, next day. Right, so we need to do the fade in, fade out thing again, like we did with scene transition. So let's reference scene transition manager with our, so it has a boolean, and let's move these to coroutine. Take all this, start coroutine, transition time, fade out. Oh, we have to wait for the screen to fade out first. Right. Instead of just wait 1 second, so that it takes a minimum of 1 second of fade out. And then we reset. We need the on fade out complete. Screen faded out. And then we reset. Maybe we put it here. Yeah, the player is able to sleep like that. That works. Okay, so now the player is able to sleep. What's left is just the saving bit. So to save, we need the game state. So let's create a new script. Game save state. It's just like crop and land save state, but it basically will be the serializable class that represents the overall save state of the game. Right, so let's open it up. It's going to be serializable, and we're going to get the font data. Our font data is the list of land save states, list of crop save states, and save the inventory as well. So it's going to save our farm data, our inventory, and time. We create a constructor. Now over in game state manager, we need a function that will export the current state of our game in this format. So let's start with our farm data. Farm data is retrieved like this, and our tool slots are retrieved from inventory manager. And you just have to do the constructor with these variables. New game save state, tool slots, item slots, create item slot, create tool slot, and timestamp. Okay, now that we are able to export the save state, we need to write this information to disk. To do that, let's create a new script, call this save, then save manager. And basically the place we want to store our save will be in our persistent data path, and then it will be slash. Let's try a JSON method. So if you just want to save it as JSON, all we need to do is convert, first take in the game save state, then we use JSON utility to JSON save. This is possible because our class is serializable. And then we use system.io, file.write all text into our file path, just like that. And to call it, we'll call it over here. Oh, this should be a static void, because we don't really need an instance of our save manager, since the instance is handled entirely by our game state manager. So game state save manager dot save. Now let's test it out. I'm going to equip myself with a hoe, till the land, advance the time a little bit, plant some seeds, and I'm going to equip myself with a pickaxe, right? And I go to sleep. Now by doing this, you should have saved this as a JSON file in this file path. The persistent data path can be found in app data, your company name, and your project name. This can be found over here in the player settings. So it corresponds. If your company name is default company, it will be saved here. And the product name is Farming RPG, or whatever you call it. Right, and now we have a nice little JSON file. And when you open it, it stores everything in the form of a JSON. Now, because I'm using Visual Studio Code to view this JSON, I can just easily format this into something readable by pressing Ctrl K and Ctrl F. Now I can see what I have. So the timestamp is day 2 at 6 AM, and I have this equipped in my to slot. Because JSON format supports scriptable object, so it's saved directly with the instance ID and the quantity. And if you looked over at our land data, you see that there's some stuff planted over there, right? And over here in our crop data, you see that we have planted some seeds, cabbage seeds, tomato seeds, and cabbage seeds. And they correspond, land ID 108. And you see it's built. Yeah, so we see that the saving system works. And if you plan to save your game in JSON, that's basically all you need to do, because JSON already supports scriptable objects. But if you don't want to save in JSON, and you want to save it as a binary save file, because if you save as JSON, you can easily just open it up and edit the values and then save again. So players can just easily cheat and modify their save file accordingly. But on the other hand, its upside is it's easy to debug. We too can read it and see what's up with it. But you might want to save it as a binary file. To do that, you have to convert the item data into a string, because the binary formatter does not support scriptable objects. So we need a new class if you want to save it as binary file. Call this item slot saved it. It's basically the same as item slot data. The only difference being, instead of item data, it should take in the string. So its constructor will take in the item slot data because that's its principal purpose. It convert it into a serializable format. Likewise, system.serializable. And we have a way to check if it's empty. And the item ID is null. Quantity is 0. If it's not, it's just going to take its name and then the quantity. Okay, with that, we can go over to game save state. and changed all this into save data. And now we have run into another problem because we're working with arrays, so we need to convert the whole item slot data array into the item slot save data array. So to do this, first we need a function that converts the slot data to item slot save data. So over in item slot data, create a function. To serialize this, we just need to return new. Why do we specifically need this function? Because we'll be using array.convertAll. Because we want to convert the entire array, right? So convert and this will take in the. Now to do this, we'll be using array.convertAll using system. So to convert all, to use this function, it takes in the array, and then so the converter takes in two types, the type we're converting from and the type we're converting to. And then next, it takes in the function that converts it, which we previously declared, serialize data. Just like this, we can convert the entire array item slot save data. So back to this. Just like that, we managed to convert the whole thing. Let's see what it looks like in JSON first. As you can see, it now stores it as a string, cabbage seeds. And then you can see the quantity as well. So it works. Now to save it as a binary file in Save Manager, extension to .save. Using string. Binary formatter is using system.runtime.serialization.formatters.binary. So just use that and .serialize our file, save file. Now if we were to save, oh yeah, don't forget it's not a mono behavior class. Don't forget to remove that. Okay, now you see you generate a save file, and we shouldn't be able to read it because it's in binary. Yeah, it's in binary, so you can't read anything. So now we have to work on loading it up. So to load it up is just the reverse. Return the game save state. So if we do it the JSON way, all it needs is check if the file exists. Then we take the JSON from reading all the text. And then the loaded save is basically just converting JSON utility from JSON into game save state. That's the JSON way. We're not using JSON at the moment. Binary method. As we check if the file exists. We take the loaded data and deserialize it, and then convert and cast it to game save state. And that's how you get the loaded save. Now let's try. Now to load, so far we have done the functions to load up the crops and all that. But we've not done the functions to load up the inventory or time. So let's do that real quick. Over in Time Manager, you add the function load time. This takes in the timestamp and set it. Put this at the top actually. And let's do it for the inventory items. Now to load inventory, we need 2 slots. The equip tool slot, the item slots, then there's the equip item slot. Yep, that's about it. Let's put everything together in Game State Manager. We'll make a function called load save for now. Then we retrieve the loaded save. Then we load up. Yeah, that's basically the 2 things the function will do. So first, to load up the save is just save manager.load. And every time we load a save, the player can only save when he's sleeping, right? So when the save is loaded, the player should be at home, basically. So the scene transition manager dot instance switch location. For the inventory, we need to deserialize everything. So item slot data. Let's take all this. We need to deserialize it. So an item slot data, basically the same thing. It's the reverse. We basically need to take the string of the item slot. It should be item save slot. Then we do the same thing here. Okay, now that we're done deserializing, we just have to I'll save slot data dot deserialize array save. Tool slots, equip tool slot, item slots, equip item slot. Just like that, the inventory is loaded, and then the time is quite straightforward. It's for the farming data, it's land manager. Just take the saves land data and crop data and save as a tuple. And that is it for loading the save. Let's see if it works. For now, as a temporary measure, let's create a little button here. And then on click, let's see if it works. So for example, I'm gonna plant a bunch of stuff, some gum, and have a shovel in my hand, and I'm going to save. So I save it should be spring 2 on a Monday with a shovel equipped, and the inventory should look like this. And when I go out, the layout should be something like this. Now let's see. Load save. Spring 2 on a Monday. I don't have a shovel equipped. There's something wrong. Oh, I see the problem. Equip tool slot should be the equip tool slot. Okay. Farmland data is not being loaded. Okay, so actually everything works. The only problem is it doesn't seem to save the land data because it conflicts with the scene changing system. So like if I were to do all this, grab a hole, and I save, as long as I'm not in the farm and I load it up, this works, right? But if I were to load it up from the farm scene, it doesn't work. Because when the scene changes, the onDestroy function is called, and then Land Manager overwrite the static variable with its own values instead. But we'll fix this in a later part. For now, it works. Because anyway, we will not be loading the save from a button. This is just for debugging. So that's it for this part. Hope you enjoyed it, and we'll see you next time.